Our universe is a vast and enigmatic stage, a cosmic ballet where two opposing forces engage in an intricate dance. These forces, dark energy and gravity, are locked in a perpetual struggle, shaping the very fabric of space-time. This cosmic dance, a delicate interplay of creation and destruction, governs the fate of the universe, dictating its expansion, its contraction, and perhaps even its rebirth. Understanding this cosmic dance is paramount to unraveling the mysteries of the universe. It's about grasping the fundamental forces that drive the expansion of the cosmos and the eventual collapse of galaxies. It's about peering into the distant future, envisioning a universe vastly different from the one we observe today. We once believed that the universe was composed primarily of the matter we could see, stars, planets, galaxies. However, this visible matter, the stuff of our everyday experience, constitutes a mere fraction of the universe's total energy density. The vast majority, a staggering 95%, is made up of unseen and enigmatic entities, dark energy and dark matter. Dark energy, the more elusive of the two, is a repulsive force, a sort of anti-gravity that drives the accelerated expansion of the universe. It's as if space itself is imbued with an inherent energy, a relentless push outward, stretching the cosmic fabric and driving galaxies apart at ever-increasing speeds. Dark matter, on the other hand, interacts with gravity but not with light. It forms a cosmic web, a scaffolding upon which galaxies cluster and form. While we cannot directly observe dark matter, its gravitational influence is undeniable, holding galaxies together and shaping the large-scale structure of the universe. Imagine the universe not as an empty void, but as a vast, flexible sheet. This sheet, the fabric of space-time, is warped and curved by the presence of mass and energy. This curvature, a fundamental concept in Einstein's theory of general relativity, is what we perceive as gravity. Dark energy, however, doesn't behave like conventional matter or energy. Instead of curving space-time inward, it stretches it outward, causing the fabric to expand at an accelerating rate. This expansion is not merely galaxies moving apart through space, it's space itself stretching, increasing the distances between cosmic objects. This concept of an expanding space-time is a profound departure from the static universe envisioned by physicists just a century ago. It implies that the universe has no center, no single point from which it is expanding. Rather, every point in the universe is receding from every other point, like dots on the surface of an inflating balloon. While dark energy drives the expansion of the universe, gravity, the familiar force that binds planets to stars and stars to galaxies, acts in opposition. Gravity is an attractive force, pulling massive objects together and causing them to clump. It's the force that sculpts galaxies, ignites stars and forms planets. Massive objects, like stars and galaxies, create depressions in the fabric of space-time. Imagine placing a bowling ball on a trampoline. The ball causes the trampoline to sag, creating a curvature. Similarly, massive objects warp space-time, and this curvature dictates how other objects move in their vicinity. This warping of space-time is what we experience as gravity. Objects are not pulled towards each other. They are simply following the curvature of space-time created by the presence of mass and energy. The greater the mass, the greater the curvature, and the stronger the gravitational pull. Section 5. The Great Cosmic Tug-of-War. The evolution of the universe is a delicate balancing act, a cosmic tug-of-war between the relentless expansion driven by dark energy and the inward pull of gravity. In the early universe, matter was densely packed, and gravity reigned supreme. This gravitational dominance slowed the expansion initiated by the Big Bang. However, as the universe expanded and matter became more diffuse, the influence of gravity waned. Dark energy, with its constant energy density, began to dominate. This shift in power marked a turning point in the universe's evolution, ushering in an era of accelerated expansion. Today, we live in a universe dominated by dark energy. Galaxies are flying apart at increasing speeds, and the large-scale structure of the cosmos is becoming more diffuse. But this expansion, though dominant now, may not last forever. The cosmic dance is far from over. Section 6, From Expansion to Contraction. The ultimate fate of the universe remains one of the most profound questions in cosmology. Will the universe continue to expand forever, growing colder and darker with time, or will gravity eventually regain control, halting the expansion and pulling everything back together? One intriguing possibility is that the dominance of dark energy is not a permanent state. Some theoretical models suggest that the strength of dark energy could wane over time, allowing gravity to eventually reassert its dominance. This would herald a new era in the universe's evolution, a period of contraction. If gravity were to regain control, the expansion of the universe would gradually slow to a halt. Galaxies currently racing away from each other would begin to draw closer. The universe would contract, becoming denser and hotter as space-time itself shrinks. Section 7. Islands of expansion in a sea of contraction. It's crucial to note that the interplay between expansion and contraction is not necessarily uniform throughout the universe. Local variations in matter density can lead to pockets of space-time where gravity remains dominant, even as the universe as a whole expands. For example, within galaxies and galaxy clusters, the gravitational pull of dark matter and visible matter can overcome the expansion driven by dark energy. These regions of space-time can continue to collapse and evolve, forming stars, planets, and even black holes, even as the space between galaxy clusters stretches ever outward. This coexistence of expanding and contracting regions highlights the complexity of the cosmic dance. It suggests a universe that is not monolithic, but rather a tapestry of different environments, each shaped by the local interplay of gravity and dark energy. Section 8. The cyclical cosmos, a universe reborn. The possibility of a contracting universe raises a tantalizing question. What happens when the universe collapses back on itself? One compelling hypothesis is that the Big Crunch, the opposite of the Big Bang, is not the end, but rather a new beginning. In this cyclical model, the universe undergoes periods of expansion and contraction, perhaps eternally. The Big Bang is not a singular event, but rather one in an infinite series, each cycle giving rise to a new universe. This concept of a cyclical universe resonates with ancient cosmologies and offers an elegant solution to the question of what came before the Big Bang. The cyclical model suggests a universe governed by feedback loops, where the remnants of one universe seed the next. The extreme densities and temperatures reached during the Big Crunch could potentially trigger processes that create the conditions necessary for a new Big Bang, igniting a new cycle of expansion and creation. Section 9. Wormholes, tunnels through time and space. If the universe is indeed cyclical, it begs the question, could there be connections between these cycles? Could there be remnants of previous universes embedded within our own, or perhaps even pathways connecting different epochs of time? One intriguing possibility is the existence of wormholes, hypothetical tunnels through space-time that could connect distant regions of the universe, or even different universes altogether. While wormholes remain highly speculative, their existence is allowed within the framework of Einstein's theory of general relativity. If wormholes exist, they could potentially provide a glimpse into the universe's past, or even serve as bridges to other universes. They could connect the Big Bang to the Big Crunch, creating a closed loop in space-time, a cosmic Ouroboros symbolizing the cyclical nature of existence. Section 10. The Grand Cosmic Ballet. The cosmic dance of dark energy and gravity is a captivating spectacle, a testament to the universe's breathtaking complexity and dynamism. It's a dance that has played out over billions of years, shaping the cosmos we observe today and dictating its ultimate fate. As we delve deeper into the mysteries of dark energy and gravity, we gain a deeper appreciation for the intricate workings of the universe. We come to see the cosmos not as a static backdrop, but as a dynamic and evolving entity driven by forces we are only beginning to comprehend. The cosmic dance is a reminder of the vastness of the unknown, a call to explore, to question, and to marvel at the wonders of the universe. It's a dance that continues to unfold, offering endless possibilities and inspiring generations to come to unravel its secrets.